Hello everyone, today I'm going to be solving the third problem from the senior contest from the CCC 2021 called Lunch Contest. Now what this problem states is that there is a number line which the field can be represented as a number line, and you have n friends standing on this long field. Now each friend has a position I, a wi, which is the time it takes for 1 meter, seconds per 1 meter. Just be careful with this because that's not the typical units for speed. And then di is their hearing range. Now, basically, what we're trying to do is trying to optimize so that it takes the least amount of time for each person to walk, and like the total amount of time is the less. So you want the minimum sum in seconds. Now, they don't tell you where the concert is going to take place, so that's up for you to decide. Now when we take a look down at the constraints for the full marks, it's up to 200,000 for friends, this ginormous number which is 1 billion for position, and 1 billion for the distance of hearing. So now we know this number line is approximately 1 billion long. So that makes any sort of regular algorithm such as a O of n completely unfeasible, because you can't try each of O of n of these spots. Now what we can do is that I can define a function, let's say f of p is equal to the sum of all times for all friends to hear you at position p. Now, when you look at these constraints and what it is, you can tell that f of p can be calculated pretty simply, and I'll get into that when we actually start coding. But what we should explore is that we're trying to find the minimum of f of p. Now, this might not be apparent at first, but f of p is actually somewhat like a quadratic function, where it somewhat looks like this. And we're trying to find this minimum right here. Now, since we don't actually know the coefficients of f of p, and we don't know anything, there is a computer way of solving for the minimum of this function that does not involve calculus or anything of the sort. It's called ternary search. Now, basically what ternary search is, let's say we take this graph again. Now, we're trying to find this spot right here, the minimum. So, you calculate two values. You split the thing into 3. And you calculate this, and you calculate this. Now if you carefully look at this value, this value is larger than this value. So like that, since this value is larger than this value, we know that the minimum of the function can't be here. Now we repeat that process again with this range. So we divide it into 3, right here, and approximately right here. And we see this value is higher, so we eliminate it. And then we just keep repeating this process until you get something and then you keep saving this as the minimum number. And you repeat this a certain amount of time. Now for this problem, there's a small calculation that goes into this, but it is approximately 2 log 2 of 1 billion. This number is basically 60, and that's the number we'll be using just so that we can ensure that we find the minimum here. Let's head over to Visual Studio Code so that I can show you this solution in action. Now what I have here in Visual Studio Code is a pretty simple programming template. Now what we should always start off with doing is getting the input. Now I'm going to define the different data structures outside of the main function so that we can have different functions that can call on them and use them, as this would be very useful for the ternary search idea. Now what we're going to have here is that we should have a vector int because it should be resizable and we have to define it first. So that's why I have the include bits /std c++sh. This includes every single header file, which should only be really used in competitive settings, as this would really slow down compile in any actual projects. So let's define 3 vector ints. We should have one for p for position, W for the walking speed, and D for the distance of hearing. We should also define N as the amount of friends. Now in our main function, we can input these numbers. So we can N, and then we should probably start by resizing all of these arrays. So p dot resize N, and then quickly doing the same thing for W and D. Next up, we should probably get the input for all of these numbers. So we should have for int a equals 0, a smaller than n, and plus a, so this just loops through everything n times. And cn, the position of a, the walking speed of a, and the distance that a can hear. Now there's one other thing that we should probably consider. Now, but I'll get to that later. Now, the second thing that we should probably get to is to write the function that tests how long it takes. Now, we should actually return a type of long because it might not fit into a 30-bit integer, and that's just to be safe. And let's call this function move, as for the time it takes to move. And then we can take an integer like int x for position, for example. Now, what this function is, function that takes the position of the concert and returns the time it takes for everyone to hear it. Now what we're gonna do is we are going to check for each friend. So for so we're just gonna keep track of every friend. And we should probably have something out here like long time equals 0. So for each of the friends, we want to get like the range of left and the range of right that they can currently hear right now. So let's just say int RL for range left equals, so the position that they are minus the distance that they can hear, and then plus for right, so RNR, range right. Now the first thing that we should check, which is like the base case, is check if the friend can already hear concert. I'm just gonna do loop through each friend, and then this is right left hearing range. Sorry. And then now how do we know if the friend can already hear? So if the concert position x is greater than or equal to the range of left, and x is smaller than or equal to range of right. Now notice it's equal to because right at the range you can still hear it. Now if in this case we'll just do continue, so that we can just loop on to the next friend and handle that. Now, I'm going to do a little trick right here. So I'm going to assume that the closest side to, so in closest equals, let's just say the right side. Now, if the absolute value of x minus side left, R and L is smaller than absolute value of x minus r and r, then that's the only time we'll change it to closest equals to r and l. So that means this is just a pretty simple. This is just a really simple true. So it's like instead of having two if statements, this is a really easy way to shorthand it. So you assume it's one value, and if it's not, you change it to the other value. Now all we have to do from now on is just calculate the time it takes them to walk. So time plus equal to, and we're going to cast it to type long, walking time of A times the absolute value, so the distance of C minus closest. Now this is just closest, and not C, X, close. Now what this basically is just the walking time for you to hear it just at the range. So that's like the minimum walking time. This is a pretty straightforward function. Nothing really cool about this. It's just each friend you find how long it takes. And the last thing that we just have to do is return time. Now let's get into our cool stuff. It's the ternary search. Ternary search for function minimum. Minimum. This is just getting input. Okay. Now, so basically, because of the calculation we made, that's about 60. We can set the position to 60. So for int a equals 0, a smaller than 60, which is it iterates 60 times. Now a is really just an unused variable. All that's there for is just to keep track of the 60 times that it's iterating through. And we should also keep track of a best. So let's do a long best equals 1e18, which is 10 to the 18. Now this is way more than the maximum that you'll be outputting. So that's why we're always going to take the minimum of this. So we're just setting it to a dummy value right now. Now what we're going to do is we're going to use the ternary search. Now the way that we do this is that we can define an integer delta, which is equal to, that's the problem that I was about to get to. Now it's going to be equal to the left, so I'll just do this right now. Right minus left is divided by 3, because we want to find the distance between like a third of them. But we don't really have the integers right and left defined. Now, if we wanted to do this a naive way, you can always just say integer L equals 0, right equals 1 billion. But just for a bit of extra optimization, we know that the constant wouldn't be more left than like your leftmost friend, and it wouldn't be more right than your rightmost friend. So let's do a bit of extra optimization and do like a O of n check to see where the leftmost and rightmost point in this loop right here. Just for a bit of extra optimization. So we can have a int L equals 1e9, which is the maximum, and int right equals 0. So these are the two these are the two like dummy values of what it would be, but we're gonna try to reduce these values. So what we're gonna do is L equals to the minimum of left and P of A, and then we can also do right maximum. Right is equal to the maximum of position of A. So we're trying to get like the most rightmost point and the leftmost point on the L and R. So that's the part I skipped a little bit earlier, just because it makes more sense to code it right now. Now that we have our delta, so what the delta is just the difference between the different midpoints that we're going to be calculating. So basically the two midpoints are going to be like, I'll call them m1 equals left plus delta, and then int m2, which is equal to right minus delta. And that comes right back to our idea of dividing it in 3, and you just calculate the two midpoints. Now basically, the next part is pretty self-explanatory. I'll just take a long, let's say x1 equals to the move, which is a function we defined right here. And we're going to do m1 here. And then we're going to do the same thing for x2. So once again, coming back to like those 2 points, that idea again. And then now we take the best. So best, since we're always finding the minimum, we'll just do best is equal to the best equals to the minimum of x1 and best, and also x2, and so we're always just taking the minimum. And then we do this little check where it's like, if x1 is greater than x2, then that means it can't be from 0 to x1, like, or from left to x1. The minimum can't be there. So we just move the left constraint up to m1, which is where we had it, and then else right equals to m2. Now there is a corner case where the minimum is right on the middle line, but since we're always just taking the minimum, this will be perfectly fine. Now we're right about done solving this problem. The last thing that we have to do is see out the best, and I'll just do n9 just for good sakes. Now let's run our test cases. And as you can see, everything passes with a very good time complexity. And this exact code gave me 15 out of 15 in the contest. So this algorithm actually does work. Now altogether the time complexity is about O of n log n, because this is logarithmic complexity. It's not really n, it's n log p, I guess. And n is because of the O of n loop to calculate the time it takes to move. So altogether, that's how it makes O of n log n. And this is how I would solve Senior 3 from the 2021 contest. Thank you very much for watching, everyone. I hope this tutorial helped you out. And if you enjoyed, consider dropping a like and subscribing for more tutorials that are similar to this.